Hello, grade 12. So we are going to go through the naming part, right? Which is like one of the most challenging, but I will show you the easiest ways, and it's really nice. So we're going to go through the IPAC naming, but before that, before we go through the steps of IPAC naming, we should try and get some of the highlights to guide us through the steps. So the first highlight is that the number of carbons. If ever you see one carbon, it represents meth. Two carbons, it's eth. Three, it's prop. Four, it's but. Five, it's pent. Six, it's hex. Seven, it's hept. Eight, it's oct. And nine, non. And 10, it's dec. But mostly the structural formulas do not go that long until number 10, right? But just to be on the safe side, you should know the name, how many carbons are there. If ever you have 10, definitely you will name it dec, right? So another highlight is that whenever we are naming, you should have a prefix, your stem, and also your suffix. The prefix stands for the number of carbons, right? These are the number of carbons, and then the stem, it represents which homologous series, the family slash. The suffix, it represents the end name of the homologous series, the end name of the homologous series. So if ever you forgot the end name of different homologous series, you should try and go back to the previous videos whereby I entail different homologous series and also their end name. So another highlight is the alkyl group. Alkyl groups, they stand for the branches. In other words, it's the branches. So the steps of IPAC naming, there is a step whereby you have to find the longest main chain. The longest main chain. So in your longest main chain, if ever there are other carbons which are not included in your longest main chain, it means they stand for the alkyl group, the branches, right? If ever you have one carbon outside your longest main chain, it means it's methyl. And if there are two ethyl, three propyl form, it's butyl, right? Further going, if ever you have two sets of same branch, you have to put di before the alkyl group. For example, I've written dimethyl. It means I have two methyls which are not included in my longest main chain. So that's why I have written dimethyl, and they are in the same set, right? Three set of the same branch, you have to put tri before the alkyl group. Trimethyl, it means there are three other carbons which are not included in my longest main chain. So we are going to go through the steps of naming, and also we're going to name different homologous series using the structural formulas. So we're going to go through steps of IPAC naming. The first step is that you have to find the longest main chain. Number two, write the number of your main chain. Number three, I beg your pardon, it's determine the homologous series. Number four, determine the number of carbons. Number five, determine the bonds or halogens. Then number six, write the name. So we have two examples here. It's example 1 and example 2, right? So on the first structural formula, this is a structural formula. So we're going to try and name it, right? So we have the first step says you have to find the longest main chain, right? You have 1 2 3 4 5, 1 2 3 4. So you can see that our longest main chain, it's 5. It's 5, right? So you can write it as 1 2 3 4 5, just for guidance, right? So and then as you can see that this carbon that is not included in your longest main chain, it serves as the alkyl group, meaning it's the branch, right? So the first thing is that you have to name the branch first. You have to name the branch. So in which carbon is the branch connected? 1, 2, 3. It's 3, but it's one carbon. It's 3 methyl. It's 3 methyl. So as you can see that these are all single bond, and the homologous series for which has all single bond, it's the alkane. But how many carbons are here? 1, 2, 3, 4, 5 in your longest main chain. So it's going to be pent pent pentane. So it's 3 methyl pentane. The 3 methyl, it says on the carbon number 3 we have a branch, right? And also the pent, it says the longest main chain we have 5 carbons, and also the end name, it represents that it's from the alkane, which we saw that because they all have single bonds, right? This is the name of our example 1. So coming from example 2, we have to find the longest main chain. So the longest main chain is 1, 2, 3, 4. Please do not confuse this chlorine as your carbons. So we have 1, 2, 3, 4, 1, 2, 3, 4. So you can write it as 1, 2, 3, 4. Right? This is your longest main chain. Just know that you have branches, right? You have a branch, and also you have other branches which are halogens, right? So before, in structural formulas whereby you have branches, you have halogens, you have to write out the halogens first. So it's the halogens are bonded on the first and the second carbon. It's 1 and then comma 2, right? It can tell us that it's number 1 and number 2. But we have two set of the same halogen. This rule also applies to the halogens also. We have two set of the same halogen. It means we are going to have dichloro, 1.2 dichloro, right? And then 1, 2, 3, 4. And then do not forget your alkyl group, which is it's methyl. It's bonded on the second carbon. It's 2 methyl. And 1, 2, 3, 4. 2 methyl bute, right? On your longest main chain we have 4 carbons. That's why we have written bute. And which homologous series does this structural formula belongs to? So as you can see that we have halogens and also the single bond. It means it belongs to the haloalkane, right? So we have written out our halogen here, so it means we're going to write A at the end. So the name of this structural formula is 1.2 dichloro, therefore it's 2 methyl butane. So we have the third example. This is a structural formula. By just taking a look at this structural formula, you can see that we have a double bond. So it can tell you something about this structural formula, about where it belongs to, which family it belongs to, right? So you're going to go through the steps. You have to find the longest main chain. So basically this one is the straight chain 1, 2, 3, 4, right? It doesn't have branches, so this one is very easy. You can write 1, 2, 3, 4, right? So how many carbons? We have 4, we have 4 carbons, we do not have branch. So it's but, right? You have to indicate um whether the double bond is bonded on which carbon, right? So it's number 1 and 2. Number 1 and 2. So it means it has bonded but2. And taking a look at the structural formula, the double bond tells us that this structural formula belongs to the family of the alkenes. So that's why our end name is going to be in. But to in. That is the name of this structural formula. So the fourth example, it's not so long, it's not so complicated, but it's doable. We have to find the longest main chain. 1, 2, 3, 4, 5, 6. Right? Okay. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So our longest main chain is 6. You can write it out as 1, 2, 3, 4, 5, 6. As you can see that we have our branch, right? That carbon that is not included in our longest main chain. So on which carbon is our alkyl group bonded on? It's 1, 2, 3, 4. It's 4. It's 1, right? So it's 4-methyl. 4-methyl. Definitely. And our longest main chain, we have 6 carbons. It's hex, and therefore we have to include our double bond. It is bonded on the first carbon. Yes. 1 I ein represent the end name because we can see that it's a triple bond, right? So the name of the structural formula is 4-methyl hex 1 ein. So let's name this structural formula. It might seem tricky, but it's very easy, right? So okay, what I catch on this structural formula is that my double bond of oxygen is bonded on the first carbon. So already my mind clicks that it's an aldehyde, right? So I have to count my longest main chain. It's 1, 2, 3, 4, 5, 6. And then it's okay, let me start from here. It's 1, 2, 3, 4, 5, 6, 7. Right? 1, 2, 3, 4, 5, 6, 7. Yes. So my longest main chain is it's 7. It definitely, my number of carbons, it will be going to be hept. So it's hept. It's heptane. It's heptanol. Heptanol. So that's how we're going to write it, and this is the name of this structural formula. So the next example, it's example number 7. um so as from before, we start off by counting the longest main chain, 1, 2, 3, 4, right? But you can see a double bond of oxygen. So a double bond of oxygen on a carbon that is between 2 other carbon is a ketone, right? It will always be a ketone, and there's no other oxygen that is involved in this structural formula. So it means the structural formula, it's a ketone. So how are we going to name this? So it's 1, 2, 3, 4. It's but and 1, 2, 2 in own. Sorry, beg your pardon. Sorry, it's own. This is the end name for the ketone. It's but2-one or butane. You can write it as butane to own. This is also acceptable. So our example number 8. Just take a Okay, let's take a look at example number 8. Just take a 1 minute looking at it, and what you can observe from the structural formula by taking a look at the characteristics. We have a double bond of oxygen, and we also have the hydroxyl group. So by taking a look at the structural formula, it means by combining the carbonyl group and also the hydroxyl group, it can tell you that this is a carboxylic acid, right? So how are we going to name it? You have to find the longest main chain. That's how we roll. You have to find the longest main chain, guys. So it's 1, 2, 3, right? You have 3 carbons in our longest main chain. So it's propanoic acid. So simple, right? So we have example number 9. By taking a look at this structural formula, we can see that this one, it's an ester, right? I forgot to write the double bond of oxygen, to include my double bond of oxygen. Right. So esters are composed of alcohol and carboxylic acid. So from this side to the left hand side, it's the alcohol, and from this side until the right hand side, it's the carboxylic acid. So how do we name esters? So we name start off by naming the alkyl group. The alcohol will stand for the alkyl group. So how many hydrogens, I beg your pardon, carbons are there for the alcohol? It's 1, 2, 3, right? So it's propanol, right? But as we name it, it will serve as our branches. It will be propyl, right? It's propyl, and we have one carbon onto our carboxylic acid. So it's propyl methanoate. Methanoate. So this is how we name esters. You have to name the alcohol first, which stands for the branch, and also you include the other carbons for the carboxylic acid, which is meth, right? That's why our name is propyl methanoate. Thank you.